I'll tell you something. When I was a kid, I can't remember what, my mum dragged me to, I can't remember, it was a stately home somewhere. And I was a bit bored, and I was going around the stately home. It was all a bit boring. And I remember there was a big staircase that came down, and at the foot of the stairs, there was a suit of armor holding a spear, like that. And I thought, when I'm a grown up, what I want at the foot of my stairs is a spacesuit. And finally, we have one. Not just any old spacesuit. It's an Armstrong spacesuit, so it's even better. It's an Apollo spacesuit there, if you could have a look at. Listen, I'm so glad you're here, because we've been absolutely bombarded with space questions. I've just been doing a session with Dr. Susie Imber, and we've been talking about being an astronaut and what that takes, and we've been talking about how spacesuits work and how spacesuits are made. But I've got lots of astronomy questions, and I'm hoping you're going to be able to help me out for half an hour or so.
Yeah, let's hope, right?
There's some tough ones, and I've set a challenge is to try and ask a question that you won't be able to answer.
That's not going to be difficult, trust me.
Well, I think so, but also I think those are the questions that I think are the most interesting questions as well. Yeah. It's the stuff we don't know in science that I'm particularly interested in. Just very quickly, just tell us a little bit about yourself. So you're at Durham University. You're a professor. You're a doctor. You're a reader. You're a
I'm a doctor, associate professor at the university. I now spend a lot of my time doing public engagement, so talking to people about the activities that we do in Durham, but I am an ex-astronomer. Gamma ray astronomy and particle physics is my background, basically.
Right. Yeah. And what was it for you that got you into space, particularly when you were younger? What was it that kind of really piqued your interest, do you think?
Tricky. I guess just looking up at night. It's the cliched answer, but just looking up at night under a clear sky. The first time, because I grew up in a city, the first time I went into the countryside and looked up, I realised there was an awful lot of stuff out there that I'd never seen before. And it was that wow moment, I think, that got me sort of, wow, what's all that about?
I think that's the same for so many people. We were talking about that earlier, just lying on your back at night and looking up. And actually, we started off today we had a picture from the Hubble telescope, that Hubble Deep Field image, and it's such an extraordinary picture. And later on today, we're going to be talking to Kathy Sullivan, the astronaut, who actually put the Hubble in orbit. So we're going to talk to her about exactly that, about looking up into the sky. Okay, I've got some questions coming in, and they're tough. Oh dear, are we gonna? Oh dear, hang on. We're gonna also. Well, we'll start off with an easy one.
Good.
And then we'll build up into like some really deep space physics. How about that? Well, I'm not quite sure who these have just been texted to me. This is a really good question, actually. How hot is the sun, and will the sun ever go out?
That's a good question. So I'm gonna share my screen with you if I can.
Yeah.
Just to put a picture of the sun up. Here we have a picture of the sun, right? Hopefully, Fantastic. Can you all see that? Because I can't see what you can see.
Yeah, I can see it.
Okay, cool. So as you all know, the sun is a star. It's our star. I mean, in terms of space and the universe, it's not particularly extraordinary. It's an average, middle-aged, average-sized sort of star, so nothing
like
special.
Myself.
But for us, it's very important. Obviously, it's our star. So there's a picture of the sun. I mean, we see it in the sky. It looks quite tiny, really, but it's so far away that, it really is an enormous ball of hot gas. And before I answer the question about temperature, just to give you an idea of how big, if I was to put the Earth on this picture, then the Earth would look that big. Right? So we can
I can't even see it.
Yeah, well, we can fit roughly just over 100 Earths side by side.
Oh, wow, there we go.
Center of the sun. It's just remarkable. And as the question implies, the sun is very hot. This is hopefully the video is working okay. It's not.
Yes, it is. It's working perfectly.
Good. So the sun is a hot ball of gas, as I've said. And it's a funny thing that there's still a mystery about the sun. The temperature of the surface of the sun, which is what you can see there, is around about 6,000 Celsius. So what's that? 60 times hotter than a cup of boiling water. So it's hot, but not amazingly hot. But if you burrow down into the center of the sun, the temperature goes up to millions of degrees there. It's an amazing thing. As you move away from the center of the sun, the temperature goes down from these millions of degrees to around about 6,000, as I've said, at the surface. But what's really quite interesting, and because we still don't know the answer to it, is that if you go away from the sun, there's a sort of what's called the solar corona. It's sort of like gas that streams away from the sun in all directions. Now, you can't see it normally because the sun's very bright, but when we have a solar eclipse, and I've got a picture of a solar eclipse here, you can see that this corona, all these streams of gas that are moving away from the sun. And what's interesting is you'd think that as I said, you move away from the center of the sun, the temperature goes down. And you'd think that as you move away from the surface of the sun, the temperature would continue to drop. But in actual fact, the corona, the temperature goes up. It goes back up to millions of degrees again, and we have no idea how that works or why it happens.
That's
So
fascinating.
there's no one answer to how hot is the sun. It depends where you are, basically, if you're in the center or the surface or beyond it. Yeah.
And will it go out? Is it ever going to stop? It's been around for a while.
Yeah, yes, it will. The sun, as we've said, is a big ball of hot gas, and the sun shines it's basically made of hydrogen gas, a very light gas. And it shines by sort of turning that gas into other things. We talk about burning, but it's not really like burning paper or coal. It's a different kind of burning. But nevertheless, you take the hydrogen and you change it into something else. Just like when you burn a piece of paper, you take it, you change it from paper into carbon or whatever. And so therefore, the sun will go out eventually. It only has so much hydrogen gas that it can burn. We think the sun's about 5,500 million years old now, roughly, and we think it'll stay as a main star for about 10,000 million years. So basically, it's got 4,500 million years to go. So don't worry, the sun will be there for a long time, yes, but eventually it will go out. And when it goes out, actually, if I can, this is not particularly professional, but if
it's
I can,
brilliantly professional.
Well,
and I'm like you've even used the dreaded font with the
yes, indeed,
Comic Sans.
Yes, don't go there. So this is a picture of a star like our sun that's actually gone out, and I know you can still see it. But essentially, what will happen with the sun is, as it runs out of gas, it'll swell up and expand, and it'll swell up to a huge size. If this was our sun, then in this picture, the Earth would be roughly at the edge of that outer ring. So you get the idea, the sun will expand and spread out right across the inner solar system. So it will swallow Mercury, Venus, the Earth, and possibly Mars as it expands. And you end up then with what's left of the star is in the middle there. That white dot is what's called a white dwarf. And that's essentially the sort of the burning ember, the hot coal, if you like, that's left of what was the star to start with.
So
yes, the sun will go out. When it does go out, it'll be beautiful like this. We won't see it, of course, because we'll be toast, basically.
Wow, it's I don't know, it's sort of a bleak future, but there is something rather lovely about that as well. I think it's okay. We are on Earth, but not forever. I think we sort of take our immortality for granted, but it's a sobering thought. Oh gosh, I've got a really deep question very quickly whilst we're on this.
Oh,
this is from Mishka. Mr. Campbell, that's me, and Dr. Pete, that's you. I've heard that in some extreme stars, like neutron stars, the pressure in the core is so extreme that even quarks and gluons get pushed together, and that can create something called a strange quark. What is the nature of a strange quark? There's your particle physics put to test.
Yeah, that's good. There's a lot of words flying around there, right? But,
quark, gluon, help.
Yeah, I mean, I don't know where to start with that, really, but just to say that we're made of ordinary stuff, atoms. I'm sure most of your audience know that. Atoms are basically essentially empty space. But there's a thing in the middle called the nucleus, and in that nucleus there are things called neutrons and protons. Now, when certain stars die out, I was talking, and this graphic's very useful for this. I said at the center, when the sun dies, it will swell up gently and expand slowly, and you'll end up with what's called a white dwarf star in the center there. Stars that are bigger than the sun, a lot bigger than the sun, when they die, when they run out of gas, they don't just gently expand. They explode in what's called a supernova explosion. It's a really violent explosion. And when that happens, the stuff in the middle that is the white dwarf in this picture, the explosion is so powerful that the stuff gets squashed down really, really tight. And if you were an atom, with an electron going around the nucleus, that the electrons would be pushed into the nucleus, and all the protons and neutrons in the nucleus would be pushed together, and you'd end up with what's called a neutron star. It's so tightly packed. The matter is as tightly packed as the matter in the nucleus of an atom, and so it's a neutron star. Yeah.
We were talking. We had some questions about black holes, and black holes are essentially collapsed stars as well, aren't they?
Yes, that's right. So if that process continues, so I told you about the supernova. If the explosion is so powerful that it's pushing down on the stuff in the middle of the star so much, it squashes the stuff down so much that its gravity, because mass gives you gravity, as I'm sure your audience knows, the more mass you have, the more gravity you get. Don't ask me why, we don't know, but that's a fact. So we squash the stuff down in a really powerful explosion so that we've got so much mass in such a tiny space that there's so much gravity that the gravity sort of swallows itself up, the star swallows its star up. It's the best way I can explain what a black hole is. A black hole is a region of space where there's so much gravity because there's so much mass being squashed down that not even light, which is the fastest thing we know of in the universe, not even light can escape from the gravity. I mean, to give you a better example of that, we're on the Earth, as all you guys know. If I could take a stone and throw it really, really hard away from the Earth, really hard, at something like a speed of 11 kilometers a second, roughly, then the stone would have enough speed to escape Earth's gravity and it would zoom off into space. A black hole has so much gravity that even light, which is the fastest thing we know of in the universe, light moves at a speed of 300,000 kilometers a second. That's just fast, right?
That is.
But even light can't move fast enough to escape the gravity from the black hole. So a black hole essentially swallows light. So that's why they're black. Nothing gets out, not even light. And they're weird things. They're very strange things. It was Einstein that first predicted their existence.
I love thinking about all this stuff. You get into some very exotic physics and some very exotic science that doesn't really quite make sense, but it sends your head into somersaults, which I really, really like.
Yeah, quite right.
Here we go. This is an interesting question. Someone says, is there another hidden planet in our solar system, and where is it? Have you come across?
Okay, so
is it Planet 9 or?
Yeah, that's right. There's been talk, isn't there, of Planet 9 or Planet X, and the argument used to be that, as I'm sure, so we have the sun at the center of our solar system, and the Earth and all the other planets orbit around the sun. But the argument was put forward that if there was a planet exactly like Earth in exactly the same orbit but opposite the Earth, then it would always be, as the Earth orbits the sun, that planet would also orbit the sun, and we never actually see it because it would be hidden by the light from the sun. It would be hiding behind the sun, if you like. And so for many years, people said, well, maybe there's this missing planet because we'd never know, we wouldn't see it. Mm-hmm. Well, of course, we can figure out if there's something there by looking at the way that all the planets in the solar system move under the sun's gravity. And if there was a Planet X, if there was a missing planet in the same orbit as the Earth, we wouldn't see it, but we'd be able to feel the effects of its gravity sort of pulling on the sun in a strange sort of way and pulling on all the other planets. And we've looked for that little pull, and there's no sign of it. So there is no missing planet, I don't think.
No, it's interesting, but it's how we discovered exoplanets, how we discovered planets orbiting around other stars, is by exactly that, by seeing the wobble of stars. We can infer that there must be a planet orbiting, which is, and that was quite a recent bit of science. It's only recently we've had the engineering skills to be able to be able to see that, the last sort of 30 years or so, I guess. Yeah. Right. Okay. That's a good one. This is the big question. This is the big one for you. I don't think there's a bigger question in all of science. Are aliens real?
So that's a great question. I mean, essentially, the question that's being asked there is a question that you've sort of answered already. So, if aliens are out there, if there's alien life in the universe, essentially they need somewhere to live to start with. Now, I'm going to base my answer here on our understanding of what life is. So what I'm saying is, for aliens to live and to be like us, there need to be other planets like the Earth in the universe where those aliens could have a home. And as you've said, Dallas, until recently, we didn't know the answer to that question. Were there other planets in the universe? And now, of course, we know the answer to that question very recently, in fact. And again, I'm going to quit out just to put a slide up. Hopefully you'll be able to see this if I can find it. There we go. So there's a picture here of our galaxy, and I'm jumping ahead a little bit, but our sun is a star, as we said. It lives in a huge clump of stars that we call galaxies. All stars live in huge lumps. And again, I'm sure your audience know all this. Our galaxy is called the Milky Way galaxy, and this is a picture of our galaxy. So it's a strange picture, but don't worry too much. That we can see the strip of stars across the sky. Now, we started looking for planets beyond our own solar system since 1991, as it says there. And I can run this. It's a very quick video. It shows you the progress we've made in discovering other planets. And hopefully you can see this. You'll see little dots appearing. These are detections of planets orbiting other stars in our galaxy. And you can see the number going up. So in 1998, we knew there were 11 other planets. 99, there were 21. And now look how quickly the number starts to go. We've launched satellites and we've looked for things. And as you said earlier, the technology now is there for us to find these planets orbiting other stars. And I'll just leave it running.
Wow. And a lot of this is new telescopes like the Kepler telescope, of course, was the great planet hunting telescope from a few years ago. Wow. Look at that. Look at it. That's extraordinary. This is just in 30 years, we've gone from no evidence of exoplanets to thousands.
Nearly there. So there we are, as you've said, in roughly 30 years, we've gone from knowing there was one planet orbiting another star in our galaxy to 4,000.
That's amazing. So let's just break that down a bit. So we know now with a fairly high degree of certainty that most stars will have planets orbiting around them. That's going to be a common thing. So there's a lot of real estate out there. How do you think we're going to find life? Will it be through things like radio signals from aliens, or will it be looking at the atmospheres of exoplanets? We might detect other gases, like we saw a couple of weeks ago. We detected a gas in Venus, even.
That's right.
May be life. Where's your money lying?
Well, I think, to be honest, I'm not sure about radio signals from other worlds, but I think certainly the technology now is that those planets that we detected there, as you said earlier, they were detected by the Kepler satellite and other units, looking at stars and looking at the wobble of the stars to see if there were things orbiting them. And we can also look at stars and see if planets pass in front of the star to block out a little bit of the light. And that's how we detected those planets. With the new telescopes that are coming online, some of the planets that we know are quite close to the Earth, we should be able to directly image them. So we should be able to actually see these planets. We can't see them in a minute, but telescopes in the next 20 years, I guarantee we'll be able to see some of those planets. And we will be able to tell if they have an atmosphere. We'll be able to tell if they're green or blue, or, if there's things on those planets that look like they could be living things. And we'll be able to measure the contents of the atmosphere, which is what you've said with Venus, for example, recently. We should be able to look at the light passing through the atmosphere of these planets and determine whether there's water vapor in the sky, in the atmosphere, so whether there are clouds, whether there are gases that life produces in the atmosphere. So I think that's probably the best way. The first way certainly will determine whether there could be living things in planets in our galaxy. I'm talking about all the stuff in our galaxy at the minute.
I think it'll be such a profound bit of news. I mean, we've had lots of close calls. I remember earlier on today, I was chatting about, again, about 30 years ago, they found a meteorite, Allen Hill's meteorite, and they thought there was a little worm on it. And everyone got very excited that, there's definitely we found fossilized life on Mars. But it turned out to be a bit of a false alarm. We've had lots of false alarms. But I'm hoping in my lifetime we'll get that absolute confirmation, because I think if we find life on another planet, we can say with a high degree of confidence that life is common in the universe. It's not just us.
No, I think you're right. I mean, I think the conditions for life as we know it, as I said earlier, all these remarks are based on life as we understand it. We know that for life, it's really important that we have liquid water. And, we don't know whether there are oceans and atmospheres on those other planets, those extrasolar planets. But we do know, and again, I'm going to quit out and just drag this in quickly. We know that there are other places in our solar system where life could exist, because we know that we're pretty sure that there's certainly on these. So there are two moons here of Europa and Ganymede. They're moons of Jupiter. And there's a moon down the bottom there called Enceladus. That's a moon of Saturn that was only not long ago been discovered, really, or studied. We're pretty sure, well, we know for definite that Enceladus has oceans of water underneath a frozen crust. Liquid water, not too salty. So there could well be life on Enceladus. You know, there could be fish swimming around in the oceans on Enceladus. And similarly with Europa, that there is an icy crust, and we're pretty sure there's liquid water beneath the icy crust of Europa too. Titan's slightly different. We don't think there's any water there, but there's liquid gases, methane and gases. And it could be that life that we don't understand can exist on Titan. But if you're asking me if we're going to find life anywhere, I think it'll be probably in our solar system first, actually. Mm. But even then, that's an amazing discovery, isn't it? Because there's life not just on the Earth in our solar system, but on other things in our solar system, which tends to back up the fact that life is ubiquitous. It's everywhere, you know. And
then, of course, there's the question of, like, is there intelligent life? I mean, I don't even know if there's intelligent life on Earth. Sometimes I watch the news and I doubt it, but that's the next question. Okay, this next question is going to really test you, both as a physicist and as a science communicator. Are you ready?
I'm ready.
This is from Isabel, and Isabel wants to know, how did the Big Bang happen? Exactly.
Okay, that's the answer you're going to get.
Over to Pete.
I'm sorry, Isabel, but the answer is going to disappoint you. Well, no, it shouldn't disappoint you. We don't know. We don't know how it happened. And that actually is quite exciting, because there's a key message here for all you youngsters out there. I don't want all you to think that we know all the answers. We don't. And Isabel, if you're really interested in trying to find the answer to that question, then maybe you should become a scientist and tell us, because we don't know the answer at the minute. We do know, and for those of you who aren't sure what we're talking about, we're 100% sure that the universe hasn't been here forever. We think it had a beginning. We think the universe is something like 13,800 million years old. So 13.8 billion years ago, the universe began. And it began in what we call the Big Bang. We know that there's lots of evidence for the Big Bang happening. We can trace the origins of the universe back to roughly, at the minute, about a billionth of a second after the Big Bang. But the question is, as what caused the Big Bang? How did it happen? We have no idea about, I'm afraid. So we're doing pretty well. You know, we're getting to a billionth of a second, but that last billionth of a second is really tricky to answer the question.
Yeah, fluctuations in quantum gravity, and we can get into some deep theoretical physics. I'm not even going to attempt to, but there's the problem with that question is, how did the Big Bang start? Is that humans were so evolved to perceive cause and effect in a kind of Newtonian universe. And unfortunately, science gets very, very strange and weird when you get down to talking about things like Big Bang and subatomic
small
particles.
Things and
small things. Yeah. Okay, we've got 10 minutes left, so we're going to do some quick fire round.
Okay.
These are some questions from Greenfields Primary School.
Okay.
I think I went to Greenfields Primary School. Is that in Ponteland? Very quickly, how did you become an astronomer? Ask Tommy.
How did I become an astronomer? Well, I'll say so quickly. So as I said earlier, I got fascinated by looking up at the night sky, and I didn't realize when I was at school that you could actually spend your time asking questions about that stuff and trying to find the answers. I didn't realize there was a job in that. But because I was interested in science, I stayed on at school and did my A-levels, and then I went to university and got a degree. And because I was still so interested in those big questions, I stayed on at university and started doing research. So started asking those questions. So basically, my key message there is that I'm not genuinely nothing special. I'm not Albert Einstein. Seriously, I'm just an ordinary bloke, right? I really am, from an ordinary background. Most of my family were coal miners back in the day. I'm the first person in my family to go to university. So there's a key message there. You don't have to be super special to be a scientist, but what you have to be is interested, I think. And it's hard work. I'm not pretending it isn't, but it's not really work if you're that interested, because it's fun.
I totally agree. For me, and I'm not a scientist, but I'm fascinated by science. And the way I see it, it's just science is that thing of like just picking up, looking over stones to see what's underneath.
Yeah.
You know, it's that adventure of just trying to understand the world around us, and it's fun. I don't know how you can even call it a job. It's like you get to ask these amazing questions.
Yeah, no, it isn't a job. I should keep that quiet because we get
Don't
paid
tell
really
anyone.
well as well. But you know, it's not a proper job. It certainly isn't a proper job.
No, it's really well. It's brilliant. Anyway, let's have a couple more quick fire questions. This is a very important question. This is again from Greenfields Primary School. This is asked by Liam. Wants to know: have we found water in space?
Well, yeah. I mean, as we've said, and if that slide's still there, I hope it is.
Yes.
Then the answer, Liam, is yes. We've already answered your question. If you remember, certainly Enceladus, one of the moons of Saturn, definitely has water. It has an ocean of water beneath an icy crust. So does Europa. We are also aware that Mars has lots of water on it. It's frozen, but they've sent spacecraft in the last sort of 20 years with basically a spade. And the little robot spacecraft dug the surface of Mars and cleared the surface away. And underneath there was solid water ice, frozen water.
But even on our moon, we've got
water on Mars.
Our moon, we have water in the craters of our moon in the shadows, which have never seen the sun, particularly at the lunar poles. We have water. And the exciting thing about water, particularly on Mars, as you mentioned, is that wherever there's water, we as humans have a potential to explore, because of course with water you obviously got water for living, but you can also make rocket fuel.
No, that's right. And the problem is, you know, people say, why don't you take your water with you? Well, it's so heavy that water is really heavy stuff, and to launch water into space, it takes an awful lot of effort. So it would be better if, like you say, if we could go to Mars and melt the ice and make our own water there. It would be so much easier.
Here's a question. This is one of my questions, actually, and it's about your job as an astronomer. On a scale of 1 to 10, how annoyed do you get when people call you an astrologer?
Oh, about 12.
The trouble is, it's people, you know, the words sound quite similar, but they mean
That's right. And, you know, I looked in my stars this morning and I knew you were going to ask me that question. You know?
There you go, you see. But it's funny, though, that we still have superstitions when it comes to the night sky. I think culturally, you know, all of cultures have looked at the night sky and wondered about what it means and what it is, and have imbued it with magical properties. But that's not what you do. I just wanted to clear that up.
No, it isn't what we do. No.
Let's have a little look. Okay, life on planets. We've done that already. We've got so many questions. Gosh, this is the one that really does my head in. This is your final question. You got 3 minutes to answer this, and it's about the expanding universe. Okay. And this is something that we hear about a lot. The universe is expanding, and of course we know that because of an astronomer like yourself, Edwin Hubble, who looked at galaxies rushing away from each other. But the question is, if the universe is expanding, what's it expanding into?
Yeah, I mean it's a big question, and it's not an easy question to answer, to be honest. But the quick answer to that question is, so as you've said, Edwin Hubble was an astronomer who looked at distant galaxies and realized they were all rushing away from our galaxy, and so the universe was getting bigger, basically. And that was one of the clues as to how we thought about the Big Bang, because people argued that if the universe is getting bigger every day, then in the past it must have been smaller. And, you know, if we track that back, it must have started in a very small space, which is the Big Bang argument, as you said.
Yeah.
So I'm stalling here. You can get that. So basically,
you're doing very well.
So the basic answer is it's expanding into itself. Now that's not a great answer, but I'll give you one analogy, and if we've got time, I'll give you a better one. So imagine the universe is a flat rubber sheet. It isn't, but let's just imagine, for the sake of argument, it's a flat rubber sheet. When I stretch, and I can stretch the rubber sheet so it can expand, right? But what we're doing there is we're not making any more rubber. We're just making the rubber go further. So
it's good. It's good.
Well, it's good, but it's not perfect.
It's not quite right. The problem is, you're absolutely right. Analogy, big questions in science like that sort of transcend analogy. Analogies can only get us to the bottom of analogies, unfortunately. But it's a good analogy. Rubber sheets are good, and balloons expanding. And
balloons expanding, that's the next one, but I won't bother you. I mean, there's a famous scientist, I'm not sure if it was Einstein, who said, maybe the universe is not only stranger than we suppose, it's stranger than we can suppose. And I think that's an interesting question. Our brains are designed to think about where, to go to the supermarket, go to the football match. They're not designed to think about the big stuff and how that all works. And so sometimes you it's difficult to get a picture in your mind. And that's where physicists go to mathematics, of course, and that's important in science. You need to understand.
I think that is a really, really good place to end, actually. And that's a fantastic thought to leave these young minds with. These are all questions that we want. Certainly when I was younger, and I still do wonder about these questions. But the idea that science isn't just about collecting facts, it's about asking questions. And science doesn't have all the answers, because science isn't a thing. It's a method. It's a way of answering these questions. So it's been absolutely fantastic to hear your thoughts on some of these big questions. Any words of advice from would-be astronomers out there? How can they get into it if people want to do what you do?
Just
enough
quickly,
to do what you do.
if you're really interested, I guarantee somewhere near your home there'll be a group of I don't call them amateur astronomers, hobbyist astronomers who have their own telescopes and maybe even an observatory. If you're interested, you should go check those guys out, and I'm sure they'll be happy to show you stuff and explain stuff.
Brilliant.
Yeah.
Okay, listen, Pete, I'm going to let you get on because you're busy answering deep questions. Going on.
Not very well.
If you discover anything exciting today, life on other planets or gravity wave, whatever it is, then come back and tell us. Otherwise,
Send you an email.
We'll let you get on. Thank you. It's been an absolute pleasure.
Thank you very much.
I've loved it. Thanks
for the questions.